Hello and welcome to my short video, which is all about a new game, a new card game called Elements Kapa, which is, here's the pack, 73 cards based on the periodic table of the elements. Now this is what they look like. This is a print, and this is what, just to show you what they look like all laid out together. And the reason for this video is because there is a lot of hidden information and a certain code that I've used to sort of design the entire pack, so you can begin to understand what the table is and some of the chemistry, well, a lot of the chemistry of the elements. Now we've done 73. There are more. There's 118 elements altogether. The Russians are trying to make element 119 at the moment. It's going to be radioactive, very heavy, and it's going to fall apart. So it's not much use to anyone other than research purposes. This is the main bulk of the universe. 99.999 and so on % of the universe is made up of these elements here. Now, what we've done is we've got a superhero. I'm going to do another video explaining the individual cards and their chemistry, but that's for another day. What I want to do is in this video is to explain how the whole table works together. So anyway, on one side, very briefly, on one side we have, they're laminated by the way, matte on this side, glossy on this side. We have a short story explaining the character, this one, nitrogen. On the front we have its elements symbol and its atomic number 7. And on this side, yes, we have the story, the two games, which is one based on scissors, paper, rock, but played with fire, wind and water for the real youngsters. And this is a game where you just compare the value of your card to the value of your opponent's. But it's the lowest number that wins on this one. But that's all in the instruction pack. What is not written in the instruction pack is how this works together as a whole. Let's go through it. Okay, now the whole table is this peculiar shape, sort of an H sort of shape, for a very good reason. Again, I'm not going to go into that because there's plenty of other good videos explaining the chemistry. It's all to do with the shells and their orbits, but that's for another day. Meanwhile, how does this game work? So as I said, individually the cards will tell you an awful lot about the elements, but what I've done is, first of all, let's talk about the groups. Now the groups in the table go downwards like this, whereas the periods go across. And in the group, what I've done is I've given them a very similar costume. Now this is the alkaline metals, potassium, rubidium and so on, cesium, all the way down to francium. They look a bit like silver surfers, but they're all similar. And that's the same with, this is the alkaline earth metals, beryllium, magnesium. So they've all got similar costumes, but different. So the idea is you'll be able to remember the groups and also what order they're in, because if you notice on the cards, the characters get bigger and bigger and they take up more room on the card. If I whip over to fluorine here, and as you see, chlorine, bromine and so on, they take up more and more space on the card. Now that is because they get heavier, their mass increases, and it's all down to this number here. This is their atomic number. Hydrogen, atomic number 1. That means it has 1 proton and 1 neutron in the center and a little electron whizzing around the outside. Now the next thing to mention is the stance. Now these are all metals, and then it moves along to this area here where they're sort of half metals, half non-metals. These are gases and non-metals. The basic chemistry is these are all good conductors of heat and electricity, whereas these are poor conductors of heat and electricity. And they're malleable and ductile, which means you can bend them with a hammer and pull them out into a wire. And they are, when they're freshly cut, they're usually lustrous or silvery shiny. Now, going back over to this area here, so generally speaking, you're looking at very reactive elements here, and they get less reactive here, and then they get really reactive again up to this point here, the halogen group, and then you've got at the very end you've got the noble gases, and these are called noble because they are very unreactive. In fact, helium and neon have never joined with any other element to make a compound ever. They've only just managed to squeeze argon for a split second with fluorine, but it didn't last long. So if you look at the postures, you'll notice the noble gases are all in yoga poses because they are calm and chilled and unreactive, all the way down to radon. Now that is a noble gas, but I didn't put a yoga pose on this one because it's very radioactive and it creeps out of cracks in the ground. Nasty stuff, can cause lung cancer. Now if you look at the halogens, these are very reactive. Now the halogens get more and more reactive as you go up the group. So if you start with astatine, iodine and so on, these get more and more reactive as you go up the group. Whereas if I whiz over to this side of the table, these get more reactive as they go down the group. Incidentally, hydrogen, chemists and physicists believe that hydrogen should really be into a separate group all by itself because it's so unique. 3/4 of the universe is made up of hydrogen, and it is from hydrogen that all the other elements are made. It is the building block. But if you do squeeze hydrogen under the right temperatures and the right pressures, hydrogen will turn into a soft metal. So as you can see, as you go down the group, these characters get really quite aggressive. The most aggressive one is cesium. Francium would probably be more aggressive, but no one's actually seen enough francium in one place to do any experiments on it. Well, not with the naked eye anyway. It's radioactive, it falls apart. Which brings me on to what's called the subgroups. Now, what are subgroups? Let me just move them out the way. The first one is what's called the platinum group. Now it's these 6 elements here: ruthenium, rhodium, palladium, platinum, iridium and osmium. Now they are indicated by this spiral. There's the spiral there. There's the spiral. Right, the next subgroup is, you see this rainbow sort of sparkly effect around francium and radium. That means that they're radioactive. So when you lay the cards all out together, you can very quickly see which ones are radioactive. Technetium is radioactive. It is the first element made in a laboratory. And if we was over here, we've got these 3 nasties down here: radon, astatine and polonium. But bismuth has got a very slight radioactive halo around it. It is radioactive, but only very, very slightly. It will be the last element to survive in the universe once it fizzles out. And the next subgroup is any with these gold arm bracelets. Now these are known as the 7 metals of antiquity, and each element from the 7 metals of antiquity are associated with a planet. Now we've got Mercury with Mercury, it is named after the planet. You've got gold with the sun, silver with the moon, copper with Venus, and over here we've got tin. Tin's associated with Jupiter, and lead is associated with Saturn, and if we whip over here, we got iron, which is associated with the moon. Next subgroup, we've got what's called the alchemy clan. Now, the alchemy elements are indicated by this star, and each alchemy element has a symbol. Now, if you see platinum has got a symbol there on his hands. We've got silver. There's the symbol of forks, and so on. Now, there's 16 of these altogether. We've got iron. There's the star associated with Mars. Mars is red because of iron oxide. Is that a coincidence? And over here we've got magnesium. There's the star. There's the symbol. Now the next subgroup is the ferromagnetic elements. Now over here we've got 3 elements together. We have iron, cobalt, nickel. These are ferromagnetic, which means if you put a magnet towards them, they will stick to it. Incidentally, the polar opposite to that is bismuth. Bismuth is the most diamagnetic element, which means that if you push a magnet towards it, it will actually push it away. Right, here we have the next group. Now, lithium, if you look at the background, it's got this sort of, and beryllium, it's got this sort of explosive firework effect. If we move over here to boron, also has the same thing. Now, these 3 elements are continuously being made in the atmosphere and in the Earth's crust by a thing called cosmic ray spallation. What is that? It is where rays from the cosmos, from outer space, will spallate, which means to change, to knock off, to literally knock off an electron or a proton and produce another element. Alright, the next symbol to look at is, see this blue sort of rays here, they are X-rays. So, and there's a few of them on the table. We've got barium over there, we've got lead over here, and as you can see the X-rays won't go through. We've got selenium up here, and if selenium is hit by X-rays, it produces electricity. And way over here we have beryllium. Now beryllium, there's the X-ray, but this one's different. The X-rays go straight through beryllium, so very useful as a material if you need to make some kind of vessel in laboratories, if you're studying anything that you want to fire X-rays at, because X-rays go straight through beryllium. Another subgroup. Now, all metals to varying degrees are good conductors of electricity. You don't want to stick anything metal into a plug socket, but silver would be the worst. We've got to see the electricity around copper here, and silver. Silver is the best conductor. A little bit around gold as well, very good conductor, but silver is the king. It's the best conductor of electricity. Obviously very expensive, so we use copper in our pipes. On this side of the table I've put down the flames, or the colour of the flames that you will achieve if any of these burn. You've got a lilac flame there with lithium, you've got sodium with a sort of an orangey flame, and so on. All of these will burn with a different colour flame, rubidium and cesium. Another thing I quickly want to mention are flags. Now you see tungsten here has got a flag, the Chinese flag on it, because most tungsten is made in China, and we have a few more here. We have strontium over here, named after a town in Scotland, and if I whip over here we have, where is ruthenium? At the Russian flag. Ruthenia was a place in Russia. And over here we have gallium, there's the French flag, and germanium, there's the German flag in the background. So there's a few flags on here as well. Now the reason I developed this game is because of this. This is a traditional periodic table of the elements. Now it's very, to me at school that was really daunting and a bit confusing, so that's why, which is a shame because it is the most fascinating subject. So that's why we came up with this game here. One last thing to mention is on the cards we have these sort of flares. We've got a green one there, got a yellow and blue and so on. There's one there. Now these flares will allow you to join the cards to each other to build up the entire table. Like that. So, thank you for watching. Our website is going to be up and running in a few days' time. It's elementskapa.com. Please visit it, and thanks for watching, and happy chemistry.